Hello, Professor. My name is Prashant Kumar Reddy Thuma, and my ID is 0073378. Coming to my project is on color detection using AI, and my project objectives, you can see it's to extract the color from a given image. To do this, I'm implementing a KNN algorithm to extract the color of the imported image. The approach I'm following is I'm using the Python, which is a popular language for artificial intelligence and machine learning. And I'm using the format of Jupyter Notebook, as it can give me the freedom to go by step implementation of my model. And coming to the overview of the project, first I'm going to import the libraries required for my project, and I am going to as it's a color detection, I'm going to use OpenCV, and as my training algorithm, I use K-means algorithm, and later I need to convert the image from RGB to hexagonal conversion, uh, because the K-means algorithm needs that. And at the end, we use the testing of K-means algorithm for the data we have given. So these are the libraries I have imported: sklearn, matplotlib, numpy, and cv2. This is a short note on the imported libraries. First, for the numpy, we all know that numpy is a library used for working with arrays. It has also functions working in domain for linear and Fourier transform matrix. And matplotlib is used for data visualization, and it's more like a modification of numpy. With the sklearn, we import K-means algorithm, which is key to this project, and it provides efficient tools for machine learning and strategy. It has many, it has everything that's required for the machine learning projects and AI projects. On CV2, we use OpenCV for computer vision to read the images. And in addition to this, we also use OS to navigate through the system files and extract the files. So what's a K-means algorithm? In this project, we are using K-means. So what's a K-means algorithm? So it's a clustering algorithm, computes the centroid and iterates until we find the optimal centroid. It's more like finding the data points which are assigned to the cluster in such a manner that the sum of the squares distance between the data points and the centroid would be minimum. So the implementation will make the images to detect the color of the image based on the clusters. So in conclusion, we use K-means to extract the majority of the colors from the image. We then use the RGB values of the color to identify from a collection that have the color in them. So now I'm going to show how these steps are implemented in my code. So first I'm going to open my Visual Studio. You can see I have implemented a sklearn cluster which has K-means algorithm, and matplotlib for visualization, numpy for number for array calculations and all that, and we use cv2 for the image reading. So I'm gonna run this. Yeah, it's done. And now I'm going to import the image. So for image extraction, okay, first I'm going to read a sample image. You can see it's it's a green color. So we are trying to extract the green color image. So and I'm and I am also printing the format and the shape of the image. So yeah, so you can see I am successful in extracting the image. So I use the OS. Next, next we when you can see that the background is blurred because CV2 when it's extract the image, it won't be in the RGB. It will be in the BGR, which it's kind of reverting that. So in order to make the color like we need to get the exact image we want, so we need to revert the uh, G RGB. To get the RGB, we just need to invert the BGR. So all we need to do is to write an invert function so that it inverts the image and gives the original image we want. We can also use gray. In some cases, we use gray images in order to detect them, even if the color is unknown. So if you want a gray image, here we can also resize the image as per our need. So I'm taking a 1200 by 16 image. You can see there's a length of 1200 and the width of 600 assigned to the image. Next. Here we are changing the RGB to hexagonal. Uh, so it's the format written. It's the format needed for to convert the RGB to a, since the three parameters are length, width. So let's do RGB to hexagonal. Yeah, it's done. And we have an get image where we read the RGB, this hexagonal image into this function. So yeah, now you can see here we are using the k-means algorithm. So k-means explain what for k-means. K-means expects a flattened array as input during its fit methods. Thus, we need a reshape the image using the NumPy. Uh, then we can apply k-means to first fit and then predict on the image to get the result. Then the cluster colors are identified and arranged in the correct order. We plot the colors as a pie chart down below after doing that. So let me just run the k-means algorithm implemented. So you can see that k-means takes the number of clusters. So yeah, it's done. So now we take this method which takes a sample image as input and the number of clusters. It should give a pie chart, yeah. So these are the cluster values that since we have given the cluster value as 8, it has produced a clustering of eight random values. You can see with that. So this is the percentage of colors present in the image. So now we need to search the image based on the color. From the model above, we extract the major colors. Major colors can be seen here. This creates the opportunities to search the images based on a certain color. So we can select a color, and if it's hexagonal color value matches with, or it may be sometimes it may be close to the image color, then it would predict which image it is. So we are giving we know that green color is assigned to 0, 128. So these are the colors I want to see in my images. So I have given the values, the array values to the assigned to the particular green, blue, and yellow. So when I run these values are gonna be assigned to these, and I'm gonna extract an image directory, which is these, which are the in these. I have these images stored in my file, file directory. So these are of different colors. Now, since we have fit the method, we can see that here we are fitting the k-means algorithm with the labels. So this it will detect for each images. It will match these color values with the images. So these are all the images I have. As you can see, I have 5 images here. This you can see the code. I have implemented the length of the image so that I can get based on my images, I will get the grid. So since I have six 1 into 6 implementation direction dimensions. So now I need to match the colors. Uh, Colors we fits green, yellow. Now let's see. Well, here the match image by color. This function, it takes image, color, and threshold as an input, and the number of colors we need to detect in each images is 10. So let's run this. You can see that image colors is getting the image and the number of colors. The cluster value is to be loaded. Yes, it's done, and we convert the RGB to hexagonal. So we can fit these with the k-means algorithm, which is already trained. Now let's see the so so in this show selected images, I have taken images, color, threshold, and color match for as an input. So when we have a function that gives image, so since I have given the color as green preference, it gonna search the images with a green color. Let's see the images that are green. You can see all the green images are loaded. Now I'm gonna take blue. If I implemented blue here, let's run this. Uh, Now it's gonna be all the images should be blue. Yeah, yeah, it's the same thing I am doing down there, so it's better stop this and go for the next, or you can just run this once, run this for the blue images and this for the yellow. Let's see. think it's better to stop this because it's taking too much long. And yeah, you can see I got the green images for this. Yeah, I can just it's taking too long, but let's simulate it. Yeah, so you can, as my preference of color is green, you can see all in all the 5 pics I have uploaded the green color images or here. So the train model has precisely correctly predicted the images that has the green color. And let's test the model with the blue color. Since we have only one blue image should be detected here. Yeah, so now it's blue. Now at the end we need to detect the yellow color. So you can see I have one clear yellow picture and I have a field image which has a mix of green and somewhat yellow. So it should detect two colors to be precise. Yeah, you see, it is detecting two colors because it's treating the pale part of green as yellow. So this is considered as some negative effect on the model because with more trained data it should be detecting the images apart from these two, but but most of the part the model has precisely predicted the color based on the input image. That's it. That's a wrap up. Thank you.